Hey folks, Mr. Dell here. We are reviewing our trig ratios. So this is for right triangle trig. Um, and let's see. So this is a problem I'm taking from CPM's Math 2. Um, let's see. And this is section 8.2.2, number 8-40. So it says for the triangle at the right, so it's a right triangle. Write each of the following trigonometric ratios. The first one is done for you. So a nice little review of our trig ratios. First of all, got to have our right triangle, making sure that's in place and for us to be able to get these trig ratios set up. So it's a right triangle. And our little acronym we remember is SOHCAHTOA. So SOH, so CAH, KA, SOHCAHTOA. And that just gives us that line of what our ratios really are all about. So how they fall in line here. So we've got S representing the sine, C representing cosine, and T representing tangent, right? So S is opposite over hypotenuse. So I'll mark those out. The O represents opposite. That stands for opposite. The H stands for hypotenuse. And the A stands for adjacent. Okay, so sine is opposite over hypotenuse. That's the ratio. So let's go through and I'll show you how the ratios work here with the examples or the problem sets that they give us. So if we look at A is asking the tangent of C. So this is angle C. When they say the tangent of C, they're saying angle C. So whatever angle C is, this angle C, the tangent they're saying is AB over BC, right? Which would make sense because tangent we see here is opposite over adjacent. So opposite of the C is opposite, meaning it's always opened up to it, right? So it opens up to AB, right? So that's the opposite. And adjacent is the side length that is not the hypotenuse that creates the angle, right? So this and these two create the angle, but BC is the adjacent, not the hypotenuse. So that's why that ratio is AB over BC. So let's do each one here. So let's talk about uh, sine of C. So sine of C, here's C again. Sine is opposite over hypotenuse. So opposite, again, the angle opens up to it, opposite. So the top of my ratio is AB, and then the bottom of the ratio, the denominator, is the hypotenuse, which is the hypotenuse is always the longest side length. It's always opposite the 90, so it's AC. So that's my ratio for sine of C. So then tangent of A is the next one. Tangent of A, so now we're talking angle A here. Tangent, remember, tangent is opposite over adjacent. So again, opposite, which is BC, right, opens up to it. So BC over adjacent, which is the other leg that's not the hypotenuse that creates that angle, over AB. Okay? Cosine of C. So again, cosine here of C, there's my angle C. Cosine, it says, is adjacent over hypotenuse. So adjacent being this side length, because it's the one that creates this angle, but is not the hypotenuse, right? So it's BC. So it's equal to BC over hypotenuse, right? So that's this AC. Okay. Now let's look at cosine of A. So cosine of A, there's A. Cosine, once again, is adjacent. So now my adjacent is the AB this time. So the numerator is AB in my ratio, and the hypotenuse, A. Cosine is adjacent over hypotenuse. Hypotenuse is AC. Last one, sine of A. So sine of A, here's A. Sine of A is sine is opposite over hypotenuse. So opposite opens that way is BC over the hypotenuse AC. So those are the trig ratios for a right triangle.